So welcome students, let's see about electric dipole. So what do you mean by electric dipole? Electric dipole is nothing but two charges of equal and opposite magnitude when they are separated by a small distance is called electric dipole. The configuration of equal and opposite charges separated by a small distance is nothing but an electric dipole. So the line which joins these two charges is called axial line of a dipole. To define mathematically an electric dipole, the properties, if we have to define the properties of electric dipole, we define a term called dipole moment, and mathematically it is equal to Q into 2D. Which is mathematically equal to Q into 2D, where Q is the charge on this dipole and 2D is the distance between them. Whenever I talk about this charge on the dipole does not mean the net charge, because effectively net charge on this dipole is 0. Q plus or minus Q, it will be 0. We consider only this Q as charge on any one charge, magnitude of charge on any one charge, and 2D is the distance of separation. This is the one point. Second point is when we talk about distances, so always remember distances are measured from center of a dipole. For dipole, distances are always measured from center of dipole. Now, if I want to find electric field due to a dipole on its axial line, let's see how we can find it. If I want to find electric field because of dipole on axial line, let's see how we can find it. Say I want to find electric field at this point P, right? Then electric field, to define this electric field, first of all I have to define the distance. Let's say this point P is at a distance x, and we know this distance is d, and similarly this distance is also d, and distances we know are always measured from center of the dipole, right? So electric field at this point P will be vector sum of electric fields because of these two charges. Because of this positive charge, electric field will be like this, away from positive, so this is E1. Similarly towards this, because of this negative charge, electric field will be towards this negative charge. It will be something like this, E2, right? Now electric field at point P will be equal to E1 minus E2. Electric field because of this positive charge minus electric field due to negative charge. So it will come out to be KQ by this distance. This distance is nothing but x minus d square. Similarly, what about this E2? This E2 will be KQ by d, or you can write it as x plus d square. X plus d square. Now from here we can take KQ as common, and what we'll get is, when we take LCM, we get x square minus d square whole square, and in numerator we'll get this x plus d whole square minus x minus d whole square. Let's see what do we get on solving it. When we solve it, we get KQ into, when we open these brackets, we get x square plus d square plus 2dx, and here we get minus x square minus d square plus 2dx. So ultimately what we get is 4dx upon x square minus d square whole square. Now we know 2dx into q. Can we write it as 2k into 4? I'll write as 2q into d upon into x upon, now x and d. We know this distance d is very small, therefore we can neglect this distance and we can simply write it as x square. So ultimately what we get is x square to the square, it will be x raised to the power 4, and this are will get cancelled out, we get x cube. So ultimately we know this term is nothing but the dipole moment 2d into q. So what we are left with, 2kp by x cube. This is the formula for electric field on axis of a dipole, right? So this is mathematically a formula of axis electric field on axis of dipole. we will see more of such things. A lot of numericals will solve based on this formula. We'll see electric field in some other configurations as well. That we'll see in our regular lecture. Now let's understand about electric flux. That is also a very major component. That is a very major topic. Electric flux. So electric flux is nothing but it is the number of electric field lines crossing a particular unit area. Now say for example, if we have a charge and there are electric field lines emerging out of it, right? Now if I place an area like this, then we know these electric field lines will cross this area like this, right? So electric flux is a quantity which is nothing but number of field lines crossing a particular area perpendicularly or normally, right? So इस area से कितनी lines cross करेंगी perpendicularly, that will be my electric flux. So mathematically, if I have to write electric flux, it is nothing but E dot ds. Now ds is small area, this is d phi, and if I have to write complete flux, it will be integral E dot ds. Now this is mathematically the formula for electric flux. Now based on this electric flux, there is a very important law, that is Gauss law. Now let's see what does Gauss law says. Gauss law says that, say if I have a closed surface area, it is important to note, if I have a closed surface area and inside that area there is a some charge, and net charge, this charge is Q. Effectively total charge results to Q. Then the flux will be equal to closed surface integral of E dot ds is equal to the charge enclosed by the surface, where this S is the surface. In our regular class, we will understand these terms in detail, but for the time being, just understand this thing, that flux is nothing but closed surface integral of E dot ds, that is equal to Q enclosed, that is the charge enclosed by this surface, right? And this surface is called Gaussian surface. This surface is called Gaussian surface. So this is all about our flux. Rest we will do in detail in our regular classes.